Hey everyone, welcome back to your channel Technology Incroyable. Today we will see problem number 300 from the LeetCode, that is longest increasing subsequence. Okay, this is a medium level problem, so let's check out the problem. We have been given an integer array nums. We have to retain the length of longest increasing subsequence. So what is a subsequence? A subsequence is a sequence that can be derived from an array by deleting some or no elements. Okay, we can delete any element from the array, or we can take all the elements also. Okay, but we have to keep this in mind that we can't change the order of the remaining elements. Okay, the elements are which are remaining, we can't change their order. They have given some example. First, let understand what is a subsequence and what is a substring. Okay, let's take this is a nums array. Okay, this is a nums array. uh, Bother me for my writing. So what is subsequence? By the definition, that we can delete some element. We can delete. Okay. So we have deleted 3. Is this a subsequence? Yes, because we have deleted 3 and we have not changed the order for 1 and 2. That is, 2 is coming here after 1. Okay, 2 is coming here also after 1. So this is a subsequence. And is this a substring? No, this is not a substring because we have deleted 3. 3 is here in between. We have deleted 3. We can't delete any element in between those two elements in a substring, but it is a subsequence. So the first thing is that we have to check the length of the subsequences. But one more thing they have written, that the subsequence should be in increasing order. Okay, this is in increasing order. 2 is greater than 1. But if we take this subsequence, this is a subsequence. We have kept the order. Okay, and we have deleted 1 from this array. 3 2. This is a subsequence. Okay, it is a subsequence, but it is not in increasing order. The order is because 2 is less than 3. We have to, it is not in increasing order. Okay, but this is a subsequence and it is in increasing order too. Okay, so let's take the example they have given, that how many subsequences are possible for this. 10. Okay, 10 is a subsequence. 9, 2, okay, 5. Individually, they all can form a subsequence of length 1. This is the first thing, that individually they are subsequences. Now, second is, but here we have to find the subsequences in the increasing order. So first, we will start the pointer. So is 10 is a subsequence? Yes, 10 is a subsequence, so we have it. Now, there is no other element before that, so we have increased the pointer. The pointer came to 9. Now, is 9 is greater than 10? No. So we have to start a new. Okay, there is no element less than 9 before that, so we can't increase its length. Now the pointer came here to 2. Okay, so is 2 is greater than 9 or 2 is greater than 10? No. So 2 will also start from the starting. Now we have increased the order. Is 5 is greater than 2? Yes, 5 is greater than 2. We have found an element which is less than 5. But is 5 is greater than 9 or 10? No. So we can add 5 to this, 10 or 9. Now we have increased the pointer. It came to 3. Is 3 is greater than 5? 3 is not greater than 5, so we can't add it after 5. But we have 1. We have 2 here. Okay, at the second index we have 2 here, so we can this we can add after 2, 3 after 2. Now, is 7 is greater than 3? Yes, 7 is greater than 3. Okay, there is one more thing. Is 7 is greater than 5? Because 5 is greater than 3, so we are checking for 5 also. Okay, so 5 is greater than 3 and 7 is greater than 5, so we can add 7 here. But 7 is not greater than 9 or 10, and 2 is already covered in both this, because 2 is less than 3, so before 3 and before 5 it has been already covered. Now we will increase the pointer to 101. Okay, now 101 is greater than 7. Yes, 101 is greater than 7, so we will add 101 in these two subsequences. Sorry. Okay, now 101 is greater than 3, but it is already covered in 7 and 5. So, and likewise 2 also. But here 9 is not covered. 9 and 10 are not covered in any of this subsequence. And also 9 and 10 are less than 101. So, we can add 101 in this. Now, 18. Now comes 18. Is 18 is greater than 101? No. But there are elements lesser than 18 before that. Okay. 7 is less than 18. So we can make, there is one subsequence 257. We can add 18. We can add, this is the subsequence. We can add 2, 3, 7 and 18. It will be right. So after iterating all the array, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. There are 14 subsequences of this array. Okay, but increasing subsequences. Okay, but we have to find the longest. We have to find the longest. So this is of length 2. This is 2. It is of length 4. 4. Okay, its length is also 4 and 4. So there are 4 subsequences whose length are 4. Okay, so our solution will be 4. Answer will be 4. We have to written like this. So this we can solve this using two approaches. First is dynamic programming and second is binary search. So dynamic programming, we have to create a DP array and have to store the length of this subsequences in that according to index. I will explain that. And in binary search, we are making one sequence. Okay, and at the end we will retain the length of that sequence. We will see. Let's first check the DP approach. So we will create an array of length equals to the length of the array nums. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And as we have seen that there is one each element in this array is a subsequence in itself. So we will initialize the value as 1 in this array. Okay, 0, 1, 2, 3, 4, 5, 6 and this is 7. Now we will start from 10. Okay, is there is no element before 10 and 10 is itself a subsequence. Okay, so we have initialized it as 1. Now second, a pointer, this will be a pointer. Yeah, our pointer will start from here. Now a pointer will come here to 9. Is 9 is greater than 10? No, 9 is not greater than 10 and there is no other element greater than less than 9. Okay, so a pointer will come here and it will remain 1 only Then we will increase a pointer to next I. 2. Is 2 is greater than 9 or 10? No, 2 is not greater than 9 or 10. So this its value will remain 1 only. Now our pointer will increase. It will reach to 5. Is 5 is greater than 2? Yes, 5 is greater than 2. And till 2 we have one subsequence. Okay. So we can add plus 1. So what it will become? It will become 2. Okay. Here at the index 3 the value is 5 and the length of subsequence will become 2 comma 5. Now the next index will come 3. Okay. Is 3 is greater than 5? No, 3 is not greater than 5. So we can't add the value at index 3. But 3 is greater than 2. We have one subsequence at 2. So we can add that value. Okay. So we have plus 1 and its value become 2. At this at the index 3 the subsequence will be 2 comma 5. Okay. At index 4 the subsequence will be 2 comma 3. Till now we have found these two subsequences of increasing order. Now next a pointer will move to 7. Is 7 is greater than 3? Yes, 7 is greater than 3. Okay. Here a pointer is here now. So at 3 the index is 4 and at 4 the value is 2. So we can add 2. So its value will become 3 now. Okay. But there is one more value which is less than 7, 5. When 5 is greater than 3. Okay. 5 is greater than the value at I minus 1th index. So at 5, at the 5, the index will be 0, 1, 2, 3. Okay. At third index, we have we have this 2 comma 5, a subsequence, and its length is 2. So we can add a plus 2 to this. That's one because initially it is 1. The value at this is 1 only. So we have added 2. If there is some other length at this and it will be greater or less than, then we will take the maximum out of this 2. But here in this case the length is same for both the cases, 2 comma 7 and 2 comma 3 comma 7. So we are taking 3 only. We are taking 3 only. At this the value will be 3. Now a pointer will move to 101. 101 is greater than 7. So we will check this value. 3 plus 1 will be 4. Now 101 is also greater than 9. So at the index 9, sorry, at the for value 9 the index will be 1, and at the first index the value is 1. So 1 plus 1 will be 2. Now 10 is 101 is also greater than 10, and at the 0th index the value is 10, and in a DP array the value is 1. So 1 plus 1 will be 2. So we have to take the maximum length out of this. So we will take 4. So at 6th index for this value, the value will be 4. Okay. Now our pointer will reach the last element, that is 18. Is 18 is greater than 101? No. So we will move backward. Is 18 is greater than 7? Yes, 18 is greater than 7. And 7th is at the index 5. Okay. 5 value we have 3. So 1 plus 3 will be 4. Is there any other element which is less than 18? Yes, there are two elements, 9 and 10. And for the 9 the value is 1, and for 10 value is 2. So 1 plus 1 will become 2. But 4 is greater than 2. 4 is maximum. So our value will here value will become 4. So a DP array will become like this: 1, 1, 1, 2, 2, 3, 4, and 4. So we will retain the maximum of this DP array, that is 4. So 4 will be our answer. So let's check the solution for this. I have written in Python. First I have initialized the DP array, that is counts. Okay, its length is equals to the length of the array, nums array. Then I am iterating to for the nums array. Okay, for this dynamic programming approach, the complexity will be n cross n. And the next I will discuss the binary search approach. For that, the complexity will be n log n. The time complexity will reduce. Okay, then we are iterating. We are checking nums of I is greater than nums of j, because here j is from 0 to I. We are iterating in the nums array. Okay, now if it's greater than, then we have created a temporary list, and we are appending the value. Then we are finding the maximum out of those, maximum out of that, like maximum of 4 comma 2 comma 2, that. And then we have moving that value to the counts array or dp array. We are moving this 4 value to this dp array. And then at the end we are returning the maximum of this dp array value, maximum of this dp array value. Okay, so that's how we have solved the problem. Now in the binary search approach, what we are doing, we are making a let's stop this first. I will quickly explain you. It's easy, it's not difficult. What we are doing is, it's not exactly the resulting it will not result in this, but the length will be the longest and out of all that. Okay, so we'll start from 10. 10 will be a substring. Okay, then after 10, 9 will come. So 9 will be this. Now after 9, 2 is come. Okay, let's say these are let's initialize this. 2 will come. So 2 is here. Now after 2 we have 5. After 5 we have 3. So what we have done, that we have removed this 5 and we have added 3. Okay, because 3 is less than 5. Then after 3, 7 came. So we have added that 7 here. Then after 7, 101 came. Okay, so we have added that 101. This sequence 2, 3, 7 and 101, it's not exactly this, but the length will be the longest. Okay, 2, 3, 7 and 101, the length will be the longest. If we iterate further, then it will become 18. Then our answer will be 2, 3, 7 and 18. This will be, because the final we are finding the final longest. And how we are searching it, using the binary, that uh, we are just less than this value. Okay, less than or equals to, we are finding a value less than equals to this value, and we are replacing that value with that. So let's see the code. You will understand it. We are initializing the subsequence with the first value in the array. Okay, and we are iterating. Then if last value is less than num, then we are appending else. Subsequence of I is less than num, then we will make I plus plus, and the subsequence of I will become num. Then at the end we will be that I said that this will not exactly be the subsequence, but this may not be in this case it may, but it may not in all the cases, but the length will be the largest. Okay, so that's how your all the test cases will get passed, and the complexity will also improve. So let's see, accepted. And okay, the runtime is 148 milliseconds and it's fast. I will show you the solution again. Thank you.